Hello, this paper presentation is for the 12th International Conference on Computer and Knowledge Engineering and is titled A Survey on Semi-Automated and Automated Approaches for Video Annotation. My name is Samin Zare and this work was done in collaboration with Professor Mehran Yazdi at Shiraz University. In this presentation, I want to explain about the introduction, datasets, and evaluation parameters, types of research approaches, conclusion, and finally, challenges. Video is a more complex data structure with motion, audio, and images baked in. Yet, it allows researchers building AI systems to access more information on objects and their environment, and it leads to more accurate results. Also, annotated video can more perfectly represent real-world situations and can be used to train more advanced AI models. That means more computer vision applications, for example, ranging from sports to medicine and agriculture. In many cases, researchers and companies have found that video can provide greater output for machine learning models than images without adding cost to unlock the benefits of video annotation. Because we can get more data points from a single video than from a single image. And by focusing on only on selected keyframes, the whole process is less time-consuming. So, video analytics systems have recently gained a lot of attention because they play a practical role in a broad range of topics such as recognizing different objects and vehicles on the street in autonomous driving cars, which need large amounts of annotated data to build robust models and improve the prediction accuracy of the model. Also, it is very important that models need to retrain frequently on new label data to remain reliable. However, labeling frame by frame of video datasets manually is extremely expensive and time-consuming. Hence, the development of effective annotation systems will be crucial for labeling large video datasets. In this work, unlike most of the other paper surveys that focus on image data, we want to briefly review novel and different video annotation methods, tools, concepts, datasets, and results for semi-automated and automated approaches. And these approaches have been developed in machine learning techniques like supervised learning, active learning, reinforcement learning, and transfer learning. Therefore, researchers and experts can refer to them for better guidance. The next section in this review is about the most commonly applied datasets to analyze the efficiency of video annotating methods. These datasets are 1. TrackBeat that contains 137 videos of web and social media. 2. Davis is the one of the most well-known datasets that has about 100 Full HD video clips with fully annotated and accurate pixel segmentation. 3. that includes 678 films of various accidents, and 4. Verat, which is a surveillance dataset that includes people and cars. And finally, YouTube video object segmentation is a widespread and large-scale video dataset, including 94 object classes. Parameters can help us quickly to see if our system is performing well or not. These recall, precision, and accuracy parameters are more widely used in cases like our research work. In this work, we categorize the approaches into supervised and semi-supervised learning, active learning, reinforcement learning, and transfer learning. In supervised learning process, machines are trained to map an input to output by using prepared labeled data. And actually, this technique is still mostly used and successful in machine learning and computer vision problems. Some of the supervised and semi-supervised algorithms in this review paper are background subtraction algorithm, recurrent self-supervised learning, interpolation, and deep convolutional neural network. In other studies of video annotation, researchers use active learning, which is a special case of supervised learning. Data are labeled according to the desired output by an algorithm that queries the user interactively. And light gradient boosting machine used in gesture detection is one of the active learning algorithms. So the next technique is a reinforcement learning in which we specify a reward function that tells the algorithm when it's doing well or when it's doing poorly. And it's the job of the algorithm to automatically figure out how to choose good actions. And for example, Dueling Deep Q network is a reinforcement algorithm. The last one is transfer learning that reuses a model designed for a previous task as the basis for another. And actually, video annotation studies have widely benefited from transfer learning based networks, which can reduce the negative impact of limited data and as a result, reduce the data preparation cost. Multiple annotation maturation and deep neural network are kinds of these algorithms. Different situations require different types of video annotation. It all depends on what kind of data we are collecting and how accurate we want it to be. The most common techniques used in video annotation for AI are bounding boxes, key point skeletons, auto annotation, 3D cuboids, and finally auto annotations. The simplest form of annotation is a bounding box. If we don't have to worry about some elements of the background interfering with our data, we can use boxes as our all-purpose video annotation tools. Some types of video annotation, such as those used for AI pose estimation, require labeling specific body parts. Pose detection requires using key point skeletons. Cuboids can be used to annotate objects in three-dimensional space. This type of annotation allows us to specify the size, orientation, and position of an object in the frame. And finally, auto-annotation is the most convenient method and it is becoming more and more popular. We also introduced some research papers that provide automatic and semi-automatic video annotation tools. Today, automation tools are available to streamline the video annotation process through the continuous frame method. Computers can automatically track objects and their location frame by frame and rely on continuous frame techniques to analyze the pixels in the previous and next frames and predict the motion of the pixels in the current frame. Using this level of context, the computer can accurately identify an object that present at the beginning of the video, disappears for several frames, and then returns later. These software and tools are beneficial in making annotating video data easy in multiple subjects such as surveillance systems and self-driving cars. So, in this survey paper, we conclude that artificial intelligence and machine learning technologies have simplified the development of intelligent computer vision systems that require data annotation, especially video annotation, to reduce the human and monetary costs in these areas. However, there are challenges in training these frameworks with large amount of annotated datasets that need human annotators from different backgrounds. Therefore, researchers have worked on methods to achieve high accuracy of labeled data and as a result, automatic data annotation. So, we provide an overview of automated and semi-automated techniques and software to address a general knowledge of these ideas and definitions. We summarize these works in a table so others can get a better insight into the using techniques, datasets, and their results. This table is sorted according to their publishing year. It can be seen that approaches such as the use of CNNs, active learning, and transfer learning, like other supervised and semi-supervised learning methods, are used in the field of video annotation. However, in this work, we do not intend to conclude which methods are more practical and accurate to compare with the others. So there are still possible challenges in ours and similar works for video annotation approaches. For example, dealing with large amounts of video data with moving objects need more complex process. Also, for accurately labeling video data, we need high-quality training datasets whose providing is difficult. Moreover, choosing the most suitable software to meet client requirements is another challenge for annotators because they may not be comfortable with all kinds of platforms. And finally, providing and using datasets for annotation may contain many ethical issues, and to address this problem, we can use the distributed machine and deep learning approaches such as federated learning. Thank you for your attention, and any questions?